Okay. Shut up! I like this guy. All right, so last time we were talking about writing our own objects, right? And we created this class called dice. Now I want us to think about this as like, if you have a six-sided die in your hand, this is an instance of one of those. So for instance, here's a D6 called of type dice with 6 sides, right? Now if I wanted to create another one of these, D6, I'll just say _2 is equal to a dice 6. So now this is like in my hand, I have 2 physical dice. Okay, I have 2 6-sided dice in my hand that I can then roll both of them and get a value from each of them. These are physically separate objects. All right. Remember back at the beginning of the course, we talked about one of the jobs of programming languages is to try to allow human beings to solve problems in as close of a way as possible to the way we already solve problems, right? And that's kind of where object-oriented languages come from, is this idea that we walk through the world on a daily basis, manipulating the world around us in terms of objects, right? A bunch of you in front of you have laptop objects, you have backpack objects, you have, water bottle objects, things like this, right? And each one of those objects has abilities associated with it. If you wanted to take a sip of water, you wouldn't grab your laptop object, right? Well, hopefully not. Okay, that's not what that object does, right? So we think about the world around us in terms of objects. You're all sitting in chair objects. Those have a function, okay? Same thing, if you wanted to type out your homework, you wouldn't use the chair for the typing part of it. You would use the chair for the sitting part of it, right? So these objects play roles in our lives in terms of how we solve problems as we go through life. And all of us are super, super comfortable with that, right? As you walk through your daily life, you don't think about the things around you as being these objects, and you ask yourself, well, which of these objects is the thing I need to use to solve this problem? That's like something that, like, 2-year-olds do when they give them like the little square peg and the little triangle peg and the circle peg and try to stick them in the hole, which is the right object that fits in that hole, right? We got so used to this as human beings that it just comes naturally for us. If we want to take a sip of water, we grab the water bottle object. All right, does that make sense? So we already think about the world around us in terms of objects. We just are so accustomed to it, we don't slow down to that point where we're actually questioning. If you're going to go and type an email, you grab your phone or grab your laptop without even going through the process of saying, well, which of the 15 objects that I have on my person is the one to use for this? You don't actually go through that thought process, even though you believe me that you do, right? You're selecting the object that's around you that will solve that problem for you. All right, so now in Python and in any other object-oriented language, we now have the ability to create self-contained objects for ourselves. We can create a dice object. We can create a water bottle object. I don't know how that plays into our problem solving right now, but we could decide water bottles can be filled, they can be taken a sip from, stuff like that. All right, but we can now create our own objects, and then we have this self-contained thing. Just like your laptop has a whole bunch of functionality, just like your cell phone has a whole bunch of functionality, just like the water bottle maybe doesn't have a whole bunch, but has a couple of different functions. It might have a little carabiner, you can hang it off your backpack, that kind of stuff. All right, so we now have the ability to generate objects that we can then pass around in a nice convenient little pod. Here is a dice. Okay, you hand somebody that dice object, or that die object, and then they can use the functionality of that object, which really is going to be for rolling and then looking at the value that comes off of it, right? All right, so we now have the ability to start thinking about our problems in terms of these multi-purpose, multi-function objects, where all of those details, the variables that we're keeping track of about that object, the functions that object can provide, are all sucked into the object itself. They're encapsulated within the object. So we have a single pod that we can now carry around with us, and that guy in and of itself can perform a whole bunch of options. I don't have this giant pile of wires sitting in front of me. Like, your laptop here. You didn't come in and just start peeling wires out of your backpack and decide, okay, well, I'm going to mess with this when I have to. You have this self-contained pod sitting in front of you that has a whole bunch of functions, and the only functions you're using in class is, whatever app you use for note-taking, and then Facebook and probably whatever game you're playing. Haha. Actually had a student in that same grad class that ticked me off a couple weeks ago that wasn't paying attention in class, and she goes, well, would you, she was working on a homework assignment for that class. She was doing the Bible homework during the lecture. And I said, well, shouldn't you be paying attention? She said, would you rather me be on Facebook? That's a pretty good response. All right, so we already think about things. We're all convinced we think about things in our world in terms of objects. All right, so last time we were talking about, Dungeons and Dragons, or replace that with some game that uses dice. Everybody in here has at some point used like a 6-sided dice. It's possible if if you're not like a some kind of tabletop game player or something like that, you haven't used. How many of you have never used like a 10-sided die or a 12-sided die or a 20-sided die? Okay, so you look around, those are the non-cool people. Because only cool people play D&D, right? Okay. Have you ever tried one of the original 100-sided die? It just looks like a giant like jawbreaker that you can never get to stop, right? You got to be on a perfectly flat surface, because now they have the 100s that are in 2. Yeah. Well, it's the one that's sticking straight up. Yeah. Now there's only one in the middle. Yeah, the one that's completely flat at the top. But nobody uses that, because that's a useless die. That will because most things are not perfectly flat. So you can't get that thing to stop. It almost always ends up on the floor. So now what they do is they have, you use a 10-sided die to get your value between, the 0 and the 9. And then you have your, the other die to give you your multiplier, your scalar on that, to give you your number between 1 and 100. Or if we write a computer program, we don't have to worry about whether it stops. You just say, give me a number between 1 and 100. You want a 100-sided die? Yeah. Coming right up. D100 is equal to dice 100. There you go. Didn't even cost us a dime. Now we just say D100.roll. And we're off to the races. There's my D100 roll right there, my 51. I roll it again. There's a 90. Ooh. So, we're convinced that's a D100? Yeah. All right. Pretty convenient, right? Yeah. You want a D72? You can't buy that in the store. There are stores that actually sell like custom-sided dice for because super geeks, like Dungeons and Dragons people who then decide, well, D&D isn't good enough the way it is. They invent their own games that are just super quirky, as if D&D wasn't quirky enough, right? So they invent their own games that have very you need like a 13-sided die. Just stupid stuff. And the games are never as good, but they sound weird, so people go and buy them. If you go to these conventions that sell these types of things in the sales room or whatever, there's all sorts of people that have these different tabletop games or little widgets they've created for new games that they talk about as being the greatest thing ever, and they're just terrible. They're dumb. But then you got people like me that will go to those places, and you have these people that will reprint the old tabletop role-playing books, like pre-Dungeons and Dragons books that you can't get anymore. They reprint them, and I buy the whole set. One of them was a cool one. It's called Rollmaster. If you never played Rollmaster, look at Rollmaster for you Dungeons and Dragons cool people. All right. So we saw how convenient it was just to create a 100-sided die there. That's the power that we get now from having an object. And look how small that object is. An object has a constructor where we pass in how many sides we have. And I'm printing out self right here. Remind me, what is self? Go ahead.
It's almost like a placeholder that you can put in where then you can pass it a variable and it will return that variable.
There's a 40% chance you know what you're talking about. Well, you've explained it terribly. You may want to give it another shot. I gave a really good, concise definition for it. Go ahead.
I don't know like how to refer to it by variable, but it's just a way for the class to refer to itself within the class.
Yeah. Self is how an object refers to itself from within itself. It's how they talk about themselves. And we looked at this as an example last time where in my constructor, I went ahead and had every object just go ahead and print the reference to himself. Because it's a pointer, it's a memory address where he lives in, this is kind of like his address in the neighborhood. It's his address in system memory. And we saw down here where I created my D6 here, and inside the constructor for that guy, we would have seen, let me just dump these couple of things here so we're not muddying the waters. So we created my D6, and here's the constructor for that. Inside that constructor, we are printing what our self is. Okay? But then outside of it, we printed the value of D6, which is the memory address. And what I'm telling you is those two things are synonyms. Self inside of D6 is how D6 refers to himself from within himself because he doesn't have access to that variable called D6 in here. That we don't have any variable in here called D6. So the only way we can talk about ourselves is by using this provided variable called self. And we can prove that to ourselves right here where I created my D6, and as part of this, I'm printing out self in here. So I'm going to see a memory address. And then right after that, I'm going to go ahead and print out D6. Not D6.roll. I'm printing out the value stored inside of the D6 variable, which is the memory address where that actual dice was built. Okay, it's like somebody asking you, where's your D6? And you're saying, well, it's upstairs under the bed. You're not saying this is the D6, you're telling them where it is. Okay? So we're going to see that both of these lines give us the same value. One of them is internally printing the value of self. The other one is externally printing the value of D6. And they're the exact same memory address because self is how an object refers to itself inside of itself because it does not have access to this external variable. And we're going to see it again here with our D20, which is another instance of our dice object. So this guy is going to have a different memory address than these two up here. But we'll see that self for this guy is equivalent to what D20 holds. Clear this real quick. Well, whatever. So here's D6 constructor. So that's the printing out the value of self for D6. Here's the value of D6. Same values. Here is the value of D20, the value of self within my instance that I created for D20. And here's the value of D20 external to it. Also the same value. So we see how self is how an object refers to itself from within itself because we do not have the access to that external variable. All right, any questions on that? I think I probably advertised last time that's like one of those top 3 things for object-oriented programming. If you don't understand the concept of self, and you're not going to be experts in it yet because we're just kind of getting started with objects, right? But we fast forward, the leveraging self, or in other languages, the synonym for it is this. Visual Basic says me with a capital M, but these are all the same kind of things. They solve the same problem. They're how an object refers to itself or within itself. If you're not able to leverage the power of self or this or me, whatever, you are significantly handicapped working with the language. It's a super important tool that you use a lot. Oh, here, let me just pop open. This is some Android code, and you guys will be using it. So lots of this is here. Lots of this is here. We probably have some more down in here somewhere. Actually, we have this thing called myself down here, which is kind of a hack because I actually up here set myself equal to this. It's a weird hack thing. It'll make sense when you go and have this stuff. But evidence, I just showed you one screen, and here's all of the pieces. These are all of the individual source code files that are in there. And I showed you a single thing here. Not even a very long one, and you saw this often. Important. All right. Yeah, actually, here's even, I mean, this is a super powerful use of it. This is a constructor in Java. Here's another constructor. So we actually have two constructors for this object. And the second one actually calls the first constructor. It says, I'm going to let this guy do what he's able to do, and then I'm going to add a little bit onto that. So again, we're leveraging this keyword to call a different constructor. It's important. All right? You're going to use this a lot. And now, obviously, I've introduced this in class. This is all going to be on the final. Yeah, see, that class last night was complaining about all this. This is like easy work, right? Yeah, like it's not a problem. You're going to be doing stuff like this for the hackathon. Not quite this big, but I put up the stuff for the hackathon is going to be an Android application. So you'll be working in Android Studio like this, and you'll be building we're going to work with authentication with a database called Firebase. So you'll be creating a registration screen, a login screen, a profile management screen for, editing your name or email address or whatever, changing your password, that kind of stuff. And then some sort of little utility. Could be a dice roller, could be a mortgage calculator, could be a survey, just some simple little thing. And in the end, you'll end up with, an app. I don't know, whatever always resets like that. Yeah, it's because I plugged in and it changed my resolution on my screen. But in any case, you'll end up with an app that has multiple screens in it where you can log in. It's talking to a database in the cloud. So these are all skills that you've all experienced before, right? By using applications, right? You've all used a smartphone app that you had to log into or something like that, or you authenticated with your email earlier today, whatever it is. So and you've had to manage your profile and that kind of stuff. These are all things you've done. Now you're going to see how it's done. That make sense? So that's what you'll be, and all of your team leads, who should be contacting you today. I put the hackathon teams up on Slack. So all your team leads should be contacting you, or maybe any of the team leads already contacted you by email? Make sure you check your email. So team leads should be contacting you. They're probably going to be creating groups in Slack or something to start talking about the projects, but they've all had experience with Android Studio to some level. They might not be experts, but you'll learn something from it. Okay? Your project will not be this complex. It's going to have like maybe 4 or 5 of these, like not as bad. Okay. So we understand the self keyword. That makes pretty good sense. All right. Now, for those cool people out there who have used the D20s and D12s and D10s and things like that for some tabletop type games, pretty commonly, you're not just rolling a single die, right? Sometimes you're doing your initiative roll, you roll a D20, or you're doing your attack roll, you roll a D20. But a lot of times when you're going to hit somebody, when you're going to do damage, if you have a long sword, your damage might be like 2d6 plus 3, something like that, right? You know, you have like your sword does 2d6 damage, so you roll 2 6-sided dice, you add up those numbers, and then because maybe your guy is extra strong, you get some sort of bonus from strength. You know, that's the +3 part. Okay, so you might want to roll 2d6, add 3 to it, and get a number. That's sometimes beneficial to you. Okay, but the idea is that you're going to have a hand, you know, a collection of dice in your hand. Okay, so we're going to have something called like a dice collection. So I'm going to create a class dice collection. All right, so, and we're going to have our constructor for this guy. Remember, constructors must be called underscore underscore init underscore underscore. And then all of our functions always start off by taking self as a parameter. Because object orientedness in a loosely typed language is a little bit wonky. And this is the way they get that variable that refers to itself from within itself passed around. All right? Because we don't have a direct variable scope since we don't have to predefine variables. We go back to this Java program here. I promise you, there's this little invisible line right here that says something like this is equal to super, something like that. It's asking their parent to give them their own identity. It's defining that value of the this keyword. All right. In an older language like Objective-C, we actually see that line. Okay. In Objective-C, we would have seen a line like this: self is equal to super.init. That's always the first line in an Objective-C program, and then in the constructor, and then the last line would have been return self. We give ourselves an identity here, and in the end, the result of our constructor is to return our memory address. Now, we've already proven to ourselves that that happens right here, doesn't it? When I print out D6, don't I get a memory addressy thing? Yeah. That means this constructor returns a memory address. But we didn't write that in there, did we? When we go up and look at our dice object, did we say return self in here or anything? It just kind of magically happens because it always happens. That's what the role of a constructor is. But if you go back to an older language like Objective-C, which I'm just randomly writing Objective-C code here inside of Java, just work past that for a second. We actually did have to give definition to self, and we actually did return self at the end. All right, so, you know, some languages have things that actually are spelled out. Some languages we have to learn that it's kind of done for us because it's just always done that way. And that makes sense, right? There's things in our lives that always work a certain way. So it's handy for us not to have to do 2 or 3 extra steps. We just take for granted that, you know, when we turn the key in our car, most modern cars are fuel injected, right? So you didn't have to pull the choke or stuff like that to get, or if you have a boat, you got to pump the little thing to get fuel loaded into the engine of the boat. You don't have to do that in your car. You just turn the key, unless you have a really old car. But you just turn the key, and I promise you, there's like a little delay, and fuel is injected into the engine, so that there's something there to combust when you start cranking unless you have one of those electric cars. Then if there's fuel there's a problem. Yeah, there shouldn't be fuel. Okay, but I promise you that's happening, even though, how many of you knew that was happening? A couple of you probably did. That's not like a super, super obscure thing, but if you have a car that's a combustion engine, there has to be fuel that lights on fire in there. So in order for there to be fuel, something's got to squirt some fuel in there. Make sense? Okay, so that's we have fuel injection or injected cars today, so we don't have to do any extra work. And man, you go back a lot farther. You used to have to get outside your car and you crank it in the front to get the thing to turn on, just like pulling the chain on a lawnmower. Okay. How many of you still have a lawnmower back home where you have to actually crank it? Doesn't that suck? You hurt your back. I mean, you're never ready for that move, right? So now you get the cool lawnmowers that have the push button start, right? They just start right up, but they're too expensive. And we're, human beings, we like a deal. So we go and buy the $70 lawnmower that still has the, the chain pull. It's like not like a good chain pull. It's like really waxy cables. It's again, we're never ready to mow. So we mow the grass and we go to the emergency room. Every week we get a bone. They have like a loyalty program at Aurora Emergency Room, at least in Grafton. So wouldn't that be funny if hospitals introduced a loyalty program? Oh, the things we cover in this class. All right. So in any case, we're going to have this this dice collection. And what I'm thinking would be kind of cool is for our, well, here, let's do it kind of in a, maybe not the coolest way yet, but we'll start off with something. So we're going to have this dice collection. And what we want this guy to do is we want him to be a collection of dice. Make sense? All right. So if I need a collection of something, what are my possibilities? What collections do we know about right now? Well, I guess we know 3 now. I'll throw the one that's not the right answer out. Strings. Strings are a collection of characters, right? What are our other collection types? Lists and dictionaries. So those are our collections of things. If we want a single variable that holds multiples of something, we have we have lists and we have dictionaries, as well as strings. But strings are fairly, they're not all that utilitarian because they can only hold characters. We want to hold dice here. So I'm going to go ahead and create a dice collection. So I'm going to say we're going to call this the dice. Actually, I have to write it this way. Self.the dice is equal to, I'm going to start it off as the empty list. Because when I first created a dice collection, you kind of go and get your little bag of dice, but you don't have any dice in there yet because you spent the $2.99 on the fake leather bag that you can wear around your neck, so that when you walk around, people know you're cool. Oh, thank you. Self.the dice is just going to be the empty list. All right, and that's all we're going to do in the constructor. So we've gone to the store and we've bought something capable of holding a bunch of dice. Okay, now I want to have some functions, maybe called add. And this allows us to add something. Name that guy a dice. Okay, so you can name it whatever you want, but I'm going to call it a dice. So this add function is going to take in, always takes in self. That's just how object-orientedness works in Python. And then we're going to take in a dice that we want to add to our collection of dice. How do we add something to a list? What's the function that we use to put something onto append? We append something to a list, right? So we'll just say self.the dice, because that's the name of my collection, dot append a dice. That makes sense? So what the add guy does is he takes a dice in as a parameter and he tosses it into the collection. So when I build a dice collection, I have my little empty bag. Cool kid, necklace around my neck, walking around. Sometimes you have your initials on it, that way your mom can find you. Because everybody looks like dorks because we're in costume. Oh, if only I was kidding. See, now they hide those things under some cooler names, so they do some tabletop stuff now at the anime conferences. How many of you are into anime? See, we get different hands in this group. Say, you're the same geeks. Okay. Okay. Just anime, it feels cooler because it's there's a trend to it, right? D&D used to be cool, but it's out of fashion now. I think it's going to make a comeback soon. Okay, but anime is currently cool. So if you go to these anime conventions, inside those conventions, you'll find people playing D&D and stuff like that, because it's the same people that have had to evolve with the rest of the world. They've had to go from the dark corner into oh, I'm watching Japanese cartoons now. All right. So when we create a dice collection, we have like an empty bag. So let's go ahead and create one down here. I'm going to take these print statements out of here because we've proven to ourselves how self works. And let me go ahead and also just remove the print self from the constructor for dice, just so we don't have extra stuff printing to our screen when we run this. Here, I'll give us a little space here. I think it's a little easier to read. So I'll create a couple of dice, but before that, I mean, it doesn't matter if we do it before that or not, but I'll call this my dice bag is equal to dice collection. Okay. Now, I can do this. I can say my dice bag dot add D6, and then I can say my dice bag dot add D20. But I didn't need to have a variable to add there. I can say my dice bag dot add dice 12. I could just add a 12-sided dice to that. Because saying, well, here, I'll just so we completely mimic it, I can say I'm going to add a D6. Isn't what I have written right there the same thing as I have written right here? And aren't we just storing the value of this inside this variable? And don't variables resolve at runtime? So doesn't this D6 actually just become its value? And what's the value of D6? We've been drilling it last class and this class. If I were to print out D6, what do I see? Memory address. So the value of D6 is where I can find that actual object in memory. So this guy is a memory address. Why is he a memory address? Because that's what this guy boils down to. So at the end of the day, no matter how pretty this looks, this is going to end up being some kind of random looking memory address. That's what he will become at runtime. Similarly, this guy right here boils down to a memory address. I'm not storing it in a variable. Instead, I'm just passing it in as a parameter to my function. Make sense? All right, but I'm going to go ahead and give myself a D12 here instead of a D6. All right, so I have my empty dice bag. I created a couple of dice just because I could. I can use these external. Then I'm going to go ahead and just toss those couple of dice into my dice bag. And then I created one more dice. Go ahead.
That dot add, was that in the dice collection object? Oh.
Yeah, we wrote that guy. So our add method takes in a dice. So I pass in anything that's a dice, and what does he do? He tosses it into my list of dice. All right, so now, just in case this is something we might want to do, we might want to roll our entire dice bag. It's fireball time. All right, so we dump out our dice bag into our hand, and just roll the whole thing. Not necessarily a common occurrence, but this is our starting point for this. So I have a collection of dice objects, and I want to roll all those dice objects. Now, how many dice objects do I have in here? Generically speaking? Go ahead. Is 3 a generic answer? It's not a generic answer. What do you do? Go ahead. Which list? Okay, so try again. Yeah, self dot the dice. So I have self dot the dice, and I have the length of that, right? That's how many dice I have in my dice bag, in this dice collection. So I want to go through every one of those dice and do something to them. How do I go through every element of a collection? Whether it's a collection of dice or a collection of integers or a collection of strings, how do I go through every one of these dice? I've got 2 options here. Go ahead. Okay, so we haven't even gotten to the roll yet, but you're absolutely right. That's what we're going to do with each one, right? So this is going to be our stock for loop, right? I want to go through each element of a collection. So I can say for I in range 0 to length of self dot the dice. Make sense? I'm going to go through every element in my dice bag. Now, I could choose to do it that way. Well, let's finish writing it, and then we'll write it with the for each loop version of it. Because I actually don't need access to I here. I don't need to know I'm at bucket 0 or bucket 1 or bucket 2. I just want to go through and roll all the dice. Right? But we'll go ahead and go with it this way. How do I access the actual dice object that lives at bucket 0? How did I access the actual integer that lived at bucket 0 of the list that we've been doing for a couple of weeks? So not a trick question. We've been accessing buckets of lists for a while, haven't we? Go ahead. Yeah, so I'll say self dot the dice. That's the name of my list, right? Open square bracket. If I wanted bucket 0, I'd have a 0 there. If I wanted bucket 1, I put a 1 there. If I wanted bucket 2, I put a 2 there. In this case, I want bucket I. That makes sense? What will this guy boil down to? There's 2 answers that I'll take. There's a correct answer with a caveat that's the real correct answer. What I have highlighted there, what will that boil down to? Go ahead. You. The dice type. Tell me more.
Like it'll tell you what kind of dice is in that spot, like 10 or 6 or whatever.
Okay, so it's going to be a dice. Okay, it's not necessarily going to tell me what kind of dice it is. It's just going to be some dice. Okay, that's an acceptable correct answer, but this actually won't give me the actual dice. What will it give me instead? Memory address. It'll give me a memory address where I can follow. It'll give me a memory address that points to that actual dice in memory. Now, because I don't have to do any more steps to actually get the dice, we could say that this ultimately gives me access to that dice. That gives me access to a dice object, even though if I were to print out that value there. So here, we'll just do it like this. If I print out this value right now, and I call my roll method on my dice collection, I'm just going to get a bunch of memory addresses. So if I come down here and I say my dice bag dot roll. Now notice here, I don't pass self in here, right? It's a magical variable that's getting passed automatically. So I never actually pass that variable. It's just part of the syntax that's required. All right, so when I tell this guy to roll, what does my roll method do? My roll method goes through all of the dice I've added to my collection and just tells each one to print itself. And it's going to print a bunch of memory addresses, right? Because that's what dice are. They are pointers to actual dice objects that live somewhere. So go back here. So there's my memory addresses, specifically 3 of them, because I've added a D6, a D20, and a D12. Okay, so we seem to have the right number of dice in there. All right, that makes sense? All right, now, what do I actually want to do to each of these dice? If I'm telling I'm going to roll my whole dice bag, I'm going to go through each dice in my dice bag, and I'm going to do what to it? He already told us. What am I doing? So I reach into the dice bag, and I have a dice. What am I going to do to that dice? What do I do to dice? I roll it. I roll it. So I'm going to tell this guy to roll. And right now, we'll just print it out. Okay, so no longer am I printing out the variable of the value of the dice. I'm not printing out its memory address. Now I'm saying I want to go to the dice at that memory address, and I want to tell that dude to roll. We're calling this function right here of each of those individual dice. So now we'll see that we get rolls. This was my D6. I think I added a D6, D20, D12. Okay, so this was my D6, my D20, my D12. Okay, Now, if I'm rolling the whole dice bag, what I actually probably want is a single sum of all the rolls put together. I might want to know the individual rolls as well. That might be of interest to me, but short term here, let's just say I want to roll all the dice and just add up a massive sum. Go ahead.
I'm just wondering if it, since we have two functions, both roll, that is problematic.
No, because this roll function belongs to this class dice collection. See how it's indented underneath it? Yep. This roll function belongs to a dice object. Yeah, but good question. These guys are not in conflict with each other because they belong to their own respective objects. Go ahead.
And the dice in bucket I is the dice, the other dice object, so you can use that function.
Yeah. So in this case, let's take it a step. Let's take his question a step further because you kind of asked the same thing. Right here, this guy right here boils down to an instance of a dice object. I'm inside of the roll method of a dice collection. But when I extract this particular dice from my list of dice, what I have highlighted there will be a pointer to a dice object. I'm telling that dice object to roll himself. And that's going to call the dice version of roll. That make sense? Okay, it's no different than if you have a backpack that has a zipper on it, and you unzip the backpack and you reach in and you bring out a pencil case, and that has a zipper on it and you unzip that pencil case. I didn't accidentally just rezip the backpack. I'm working with an object inside of it. That's a pretty good example, actually. That makes some sense? So your pencil case gave me the inspiration. All right. So that's how these guys are not in conflict. Sometimes objects have similar functionalities, right? All right, so when I roll my dice collection, I'm gonna have to keep track of a sum. Now this is not self.sum, because self.sum says I want this variable to belong to this instance of my my dice collection. I really want this guy just to be a local variable. I want to locally create a variable, start it off at 0, and just add stuff to it. And I want him to live and die with this function. So I'm just going to say sum is equal to 0. And then inside here, rather than print those values, I'm going to say sum is equal to sum plus whatever I just rolled. And then in the end, I'm going to return sum. So after this for loop is done, I've gone through, I've rolled each of the dice in my dice collection. I've added the roll onto my running total of sum, and then not underneath the for loop, but outside of the for loop, I'm returning the value of sum. So what will the output of this program be right now? I'm telling my dice bag to roll. This is what the roll method for my dice collection does right here. What will the output of this program be? Go ahead.
All the dice numbers added up together.
Okay. That's what you want it to be. What it actually is right now is nothingness. Why is it nothingness? I'm testing something I've also harped on. Go ahead.
You didn't return the sum.
I did.
Within the dice collection object.
Yeah, right here. Go ahead.
Return just returns the value, doesn't actually print it.
Yeah. I have the value there. I'm just not doing anything with it. So if I want to actually print that sum, I got to print it. This is that difference between a function that returns a value versus a function that either does something or displays something like that. I did all the stuff. I definitely rolled each of the dice. I summed them all up. I returned that sum. I just chose to ignore it and didn't do anything with it. Now I'm going to print out that value that comes back, and I will see that I get an actual value. I was getting all the numbers before, I just wasn't doing anything with them. Does that make sense? So it's very important that you understand the difference between returning a value and a function that might display a value. Display a value is going to give us visual evidence. Returning a value is only going to give us visual evidence if we do something with it. Okay? And more times than not, when we write functions, we're probably writing them to return values, because especially as you've seen what we've done in class, where we write all these little functions that, each function kind of uses 2 or 3 other functions that we write. We're kind of just, those functions exist with the sole purpose of just giving us a value that we use for some other part of our program. That ultimately maybe translates into some sort of visual output, but not for a while. All right, that makes some sense? All right, so for your homework, and this is going to be a little bit of a challenge. For roll, I want to take in a roll string. And a roll string might be something that looks like 2d6 plus 8. Or it might look like something like 3d4 plus 1d6 plus 1, or just leave it like that, something like that. So it's a description of dice that you want to roll. So in this case, I want to roll 2d6s and add to that a single value of 8. In this case, I want to roll 3d4s, 3 4-sided die, and add to that a roll of 1 6-sided die. So I'm giving it a formula that I want it to roll. And I wanted to process that formula. It's kind of like process expression. Remember process expression? Where we did the math? Did math stuff. So I want you to go through this string, parse out this string, and create and roll the correct number of dice, and ultimately give me a result. Go ahead.
So would we be not telling the dice object, would we still be using those?
Yeah, you're probably going to go in here and you're going to create a d6, roll it twice, and then you'll create a d4, roll it 3 times, and a d6, and roll it once. So you'll still be using your dice objects. Go ahead. Just adding's fine. Yeah, let's keep it as simple as possible, but just, yeah, in fact, yeah, just adding. Leave it like that. That makes sense? So, should be challenging, but this is getting you practicing using our objects that we already have, and this guy is now going back and kind of incorporating in our string manipulation stuff. So you're going to walk through this string, and you're going to get a quantity that you're going to have to roll, followed by, there's always going to be the letter D in there. That's the separator. Then you're going to have the number of sides for the dice you need to create. A 6-sided die, a 4-sided die, a 6-sided die. That makes sense? Then you'll actually roll it, and you'll add it to a running total. Go ahead.
So 8's not a die?
No, 8's just a hard-coded number.
Okay. So we just add
Yeah.
it to it.
In fact, actually, let me amend it a little bit. For right now, no hard-coded numbers. That'll make it a lot easier. You only have to deal with summing up quantities of dice. That'll make it so it's always the same pattern of a number followed by D followed by number of sides. Make sense? We'll add the hard-coded number in class on Friday. It's not that bad. It just adds one more level to the assignment. So let's keep it simpler. Cool? All right, I'll put this code up on Slack, and I'll put the assignment up. And I will see everybody on Friday. Remember, Hackathon is this Saturday. Meet in the computer science room at 8 a.m. There's going to be food all day, bagels and crap like that for breakfast and all this stuff. If you do have any dietary needs, gluten-free or something like that, make sure you email joshua.locklear@cuw.edu and let him know, because you'll be getting the food and we'll get you something that's safe for you to eat. Just make sure you let him know that. All right? Stop the recording and get it uploaded before I forget.